Okay. Might be a problem. Not what you want. So yeah, third time's a charm, right? We'll see. Actually, that'll be at the end of this video, so if you don't really care to hear me babble along, just go to the end of the video and you can see the rest of the CNC where it actually works. It did work. Works great. So, but this is going to be a garage video. Maybe some of you came here for drone stuff, but it's not going to be a specific channel. It's just my hobbies. Nothing special. Don't expect to get a million views or anything like that. It's just my hobby. So today's gonna be about my garage and my machines. So 2 years ago when we moved, it was more than 2 years ago that we moved here, but the place where we did live, I had a shed and I had two machines in there. A Pratt & Whitney Model B lathe, that's a 3,000 pound 12 by 30 lathe. Pretty big old beast, pretty nice machine, kind of worn out, needed to be rebuilt, and I never did get around to doing that, scraping the ways or anything like that. So I had that machine, and then I also had a Van Norman number 12 mill. It's an 1,800 pound mill, can do horizontal or vertical. It's a very beastie, way stiffer than like a Bridgeport. But so I had that mill too, and whenever we came here, the plan was to maybe build a shed or a lean-to. Lean-to would have been up closer to the house, so I could work closer. Shed would have been in the back 40. Probably wouldn't have got out there very much. So never got around to doing that, and they sat on the trailer for 2 years, and then we had Hurricane Ida, and a big tree. It was about 24 inches around, about where it hit it fell straight on the top of the mill, pushed the mill down through the trailer, sat on the ground, torqued the trailer all messed up. Just broke a couple little arms to the gear shift lever and like a cover on the mill. Other than that, and it popped a gear off. I had to put that on the lathe and true it up just slightly. Other than that, it worked. Took me forever to get it back out of that hole that it created. But then I sold those two machines because they were sitting there for 2 years and I didn't use them. So the thought is to have smaller machines, something I can work with here in the garage. Just because I can come out here at midnight. It's I don't know what time it is right now. Maybe 9, 8 o'clock, something like that. I can come out here at night and just work, and maybe one day it would be air conditioned or something like that. Versus out in the shed, you got mosquitoes, so I pretty much wouldn't be out there at nighttime anyways. So it just kind of went down smaller. So yeah, I have the CNC mill, which you've seen that in another video. I'll talk to you about this setup in a second. And then for my lathe, right down here, I got this cheap Chinese lathe. This is like a 30-inch lathe. It's only 7 by 30. I don't know if you can see that or not. It's all dark in my... I think it's better on the actual video. But yeah, so it's a 7 by 30 lathe, Chinese lathe. So originally I started out with this little 7 by 10 lathe. Those things are quite useful. The biggest problem with them is they're small. the length, of course, is only 10 inches long, and that's, you know, that's between centers. You never hardly work with that. The other thing is the through hole on a little lathe is like 3/4 of an inch. So you, like if you're trying to turn a barrel or something like that, you can't put the barrel through it unless it's a really thin barrel. So you're trying to, you know, put threads on a barrel or something like that. Can't do that. So that was the biggest limitation with that thing. So then when I went up to my bigger lathe, you know, it didn't have those limitations. But so going to this lathe, the main things I looked for was a big through hole. So this is like a 1.5 inch through hole, and it's the 30-inch length. So I liked having that little lathe. I did a ton of work on the little lathe before I got my big lathe. It's just, I even wore out the ways on it. So I figured I'd go back to that, a machine that I didn't have to really work on so much, maybe. As didn't need refurbishing or anything like that. And it's light, like me and my wife could lift this thing versus you have to kind of like do Egyptian lifting and stuff with Egyptian pyramid building when you're lifting those big machines. But this thing, me and my wife could just lift it up here. So that was the thought, and I overlooked a few things. All the lathes that come from Viver, I guess is the company. All the lathes, they don't come with a threading gear. The thing that shows you where you can like you can unlock it, roll it back, and then lock it back down to a certain number. They don't come with that, so that means you have to keep it locked, keep the half nut locked in there. And then you got to reverse the spindle back and forth. The other thing it doesn't have is you can't reverse the thread, the feed. You can't reverse the feed other than reversing the spindle, which the little lathe had on it. I figured, you know, that little lathe, that was like 20 years ago that I bought that thing. I figured everything had those features on it because it was like the cheapest thing ever, right? But yeah, this lathe doesn't have the reverse, doesn't have reverse on the feed, and it doesn't have the threading dial. So have to get used to that, try to figure out. That's the other thing is like you can't, I assume you can't do reverse threads. Not that I ever needed to do that, but can't do reverse threads on it. So I don't know if this is going to be an okay buy or not. Haven't even used it other than take it slightly apart and adjust a few things on the carriage. We'll see. Might do some work with that. So today's project that you're going to see, the CNC, is doing battery bars. This is my golf cart here. I hope that this video shows a lot brighter than what I can see in this back screen. But so that's the battery bars there. On the golf cart, I drilled every single one of those, hand drilled and measured every single hole. It's like 100 holes. And it took me, I think it took me a couple days to do it, like off and on. I did it. I don't know how many hours of work it was. But then, like, you know, you go to put them on there and they don't hardly go. I'd have to, like, you know, file out a hole or something like that to get them to fit just right. So that was a lot of work. So the thought on this video was to do it with the CNC, and I did, and they fit like perfectly. It took me like 2 months because I was switching software. I switched to Solidworks, the Solidworks Maker subscription. It's $10 a month, and versus Fusion is free. If you're just for the same stuff I'm doing here, Fusion is free, so there is that. But I ran into several different problems with Fusion before, little quirks that it has. And the other thing is it doesn't do rapids. Between, like, for if you're just doing the free version, they won't do rapids, so like slow you down. Now you'll see whenever this thing's running, it's not doing rapids at certain spots either. It takes forever, and that's just me not knowing where the lead in, lead out should be, and where the rapids should be, and things like that. I have to figure out all that. That's like I said, it's been 2 months that I've been working with SolidWorks, trying to get it all figured out. It is a steep learning curve compared to Fusion. Especially, I mean, the CAD portion of it's easy. It's just like Fusion. You pick that up in a few minutes. The CAM portion, you know, the machining portion, is a very steep learning curve. Took me a long time. I even canceled my subscription. It was coming up due, and just like a couple days ago, so I just turned off the probably about a month ago. Told it, okay, don't renew that subscription unless I actually get this thing working. But I did. I got it working. So I went ahead and renewed my subscription like yesterday or something. So kind of sort of all in on that program. I do like it. It has a lot of options, a lot of power. Even the Maker version still has a lot of power to it. Like the high-speed machining. At first I wasn't sure if you're going to get what what Fusion calls adaptive clearing. They call it high-speed machining in SolidWorks. So it's just kind of hidden down there. You find it eventually. But yeah, so I'm working at SolidWorks. The other thing that's changed here is my setup, my computer setup. I did have a tablet here before. Now this is got a Raspberry Pi 3B on the back side here. That is running the Windows on Raspberry project. It works pretty good. The 3B is a little slow compared to say the 4B, which those things are super expensive right now, but I might be switching over to that. The only problem I'm having when I'm running the CNC, when it's running the program, it runs fine, runs great. You'll see that. It'll even crash it for you if you set it up wrong. The problem I'm having is with this pendant here. Whenever I move on here, if I'm doing a fast movement on the Y direction, which is the back and forth here, this thing, right whenever it comes to a stop, right when the Y comes to a stop, this will go like click, just like a little bit. It'll just twitch, and that's the X. So then your X will be off when you go to run your program. So I had that. You'll see that the very first try that you'll see, it was a little too far into the positive X, actually it's negative X direction, I think. It was a little too far, and that's because the X had moved on me. I didn't realize it. So then the next time I moved it back, I just make sure I zero my X as the last step, and then I can run the program. The next crash that you just saw, that's because I didn't get the lead in path right. It had a motion that came from the side and then came in and then comes in to cut. I don't know really what that's for. So I went and deleted that. You'll see it in the last video, or the video that's going to be at the end here. That I took out that motion in that last little slot. So I cut the slots so that I could have a spot that would tell me where to go and cut those off with the cutoff. It's a dry cut saw. I could have cut all the way through them, but then you have to think a little more into it about where you're gonna clamp everything down. Probably have more clamps, things like that. So what I did was just use the CNC to mark the spots that I'm gonna cut and then cut those. The main thing I wanted was accurate holes, which they're perfect. They slide right on the batteries. I'll show you a little clip of that happening. Anything else about this? Oh, I did also this little black piece right up here. So you see it's holding on the MIST kit. I 3D printed this, and I will include a link to that in the description. Thingiverse, I think it is. This is 800 watt spindle, so I think it's 65 millimeters wide. So if your spindle is that size, this will fit right on there. Now that was the reason I installed that MIST kit. If you remember from the other videos, when I did steel, it just cut right through it fine. Like I was doing 50 inches per minute, and like 20 thousandths or 15 thousandths step over. But then when I went to cut aluminum, it was galling the bit really bad. And so I'd read that you could use WD-40, so I squirted a little WD-40 on it, and that helped. But still, I had to go a lot slower. Now you'll see the speeds. I'm back up to 50 inches per minute with the aluminum on a 2-flute bit, 24,000 RPM, 20,000 step over if I'm slotting, or if it's like boring or doing like a high-speed bit. You know, I'll go down 100 thousandths and 20 thousandths over, or 20 thousandths down if I'm going full-size bit. So I can run full speed. I haven't pushed the limits on inches per minute. I just 50 was on top of my head, so that's what I used. I used 50 inches per minute, and then I pushed the step over when I was testing, just till it sounded like it was, you know, getting a little workout. I may when in the future try to up, you know, use 20,000 step over and then up the inches per minute just to see what it'll do. See if there's something. You just kind of go by the sound. I'm sure there's better ways to do that, but that's what I do. I go by the sound. I do some test strips and go by the sound. So that's how I came up with 50 inches per minute, 24,000 RPM, 20,000 step over on a 1/8 inch bit. So 25% ish on the bit. So yeah, that's the setup there. I don't remember if there's anything else. Oh yeah, I did air. This is air coming in, and I plumbed up my compressor that's sitting over there in the corner. It goes through the garage. You can probably see right up there. I got a pull down thing now too, so I can do tires or impact wrench on the car. So So kind of get my shop set up the way I want it mostly. It's a little tight, but I can work in here, late at night. So that's kind of more my style. So we'll see about this. This might get an upgrade, just to get rid of that the jerk movement that it's doing. When I was on the laptop, it worked fine. I switched that earlier today. I switched out to the laptop. It worked fine. Didn't do the extra X movement. And the other thing is, if I jog it with the keyboard, it doesn't do that movement either. So it's basically this pendant is a USB, wireless USB dongle here. So it's going over USB, and the machine is going over USB. So that's what I assume is happening, is that they're just fighting for the bandwidth on the USB, or fighting. This is probably the CPU on that the Raspberry Pi. So maybe if I go up to Raspberry Pi 4, that'll go away, because I really want to keep this set up. I don't want to put a tablet here. So anyways, next up you'll be seeing the videos of me machining that. I did have one problem. I'd made these braces here. I didn't tighten down the brace until after I tightened down the clamps, which is opposite of what I should have been doing. So one of the clamps is probably pushing this low. So you'll see that some of the holes went through, like they probably should have, and then like one or two of them I had to drill more out to get them to clear. And I think that's because it was warping the bed when I clamped them down. So yeah, you'll see that was I should have hit my clamp first, or my brace first, to stiffen the bed. So yeah. Anyways, video's coming up.